This is lesson 11.5, all about recursive rules for sequences. Now, a recursive rule for a sequence is nothing more than a rule that will involve one or more previous terms. So, for example, if I have this sequence here and I wanted to find a rule for it, the easiest one that we already know is how to find whether it's arithmetic or geometric. So if I look at what's going on here, the pattern is I'm adding 3. Since I'm adding 3, I know it's arithmetic. And so now I can just write my rule for it. I'm going to use this generic form, an equals a1 plus d times n minus 1, and I'm going to plug in my information. So an equals 5, that's my first term, plus 3 times n minus 1. And then I'm going to distribute, clean it up. And my arithmetic sequence rule would be 3n plus 2. That's an arithmetic rule. Well, a recursive rule takes into account what's the previous terms. So a recursive rule would look like this. To get my next term, I'm adding 3. And the way we note that is an is equal to the previous term. Now the notation here is going to get a little bit tricky. The way we say the previous term, well, if I'm talking A3, the previous term would be A2. If I'm talking A4, the previous term is A3. Well, all I'm doing is taking this number and subtracting 1. Well, when we start talking about n's, the previous term, to get from n to the previous term, it's going to be n minus 1. That's my notation for the previous term. Then what I have to do is say, well, I'm taking that previous term and adding 3. So this is the previous term. Along with a recursive rule, though, there's one more thing we need to always provide. And if we're going to use one previous term, we need to tell along with the rule what that first term is, because without that first term we can't generate the sequence. So along with the rule, we then have to specify that the first term is 5. This is what a recursive rule looks like. So let's see another. For this rule, I have to first find the pattern, and it looks like I'm multiplying by 3. This makes it a geometric sequence. So to write the rule for the geometric sequence, I'm going to use this general form. So it says the nth term is the first term, 2, times r, which is 3, to the n minus 1. That's my geometric rule. If I want to write a recursive rule, what I'm doing is putting it in terms of the previous term. So an is equal to, now all we did was take the term before it, so in other words, we took a1 multiplied by 3 to get a2. Then we multiplied this one by 3 to get 18. So we're taking the previous term, an minus 1, and multiplying by 3. Well, let's clean this up, though. We're going to put the 3 in front, so 3 times an minus 1 would be my recursive rule. And then again, because I'm looking at one previous term, I have to provide one of the beginning terms, a1. So there's my recursive rule. Now let's take a recursive rule and generate our list. Here's how this is going to look. Now we have the first term. We absolutely need that, because here's why. If a1 is 2, I'm given that information up above. To get a2, it says take the previous term, the one that came before it, and add 6. So I'm going to take a1, which is 2, and plug it in and add 6. So my next term is 8. To get a3, it says take the term that came before it, the previous term. Well, that's 8. I'm going to take the answer I just got and plug it in. And then my fourth term, I'm going to take a3, which is 14, plus 6. That's how I use a recursive rule. We're taking the answer we just got and plugging it right back in to get the next term. So let's see this example. Here's my previous term. I'm going to take a1 and plug it in order to find a2. I need to find the first 4 terms. So a2 would be 2 times 3. I get 6. To find a3, I'm going to take the answer I just got and plug it in. So my next term is 12. And then my fourth term I'm going to take that 12 that I just got and plug it in. I get 24. There are my first 4 terms. 3, 6, 12, 24. And here's one last example. Sometimes we use 2 previous terms, and this just says, here's the previous term, and then the a n minus 2, all this refers to is the next previous term, for lack of a better way to say it. So if these are my terms, here's an, here's an minus 1, and here's an minus 2. And for that matter, this would be an minus 3. You're backing up, okay? It's the one right before an. So to find my terms, or to find my rule, since I'm using 2 previous terms, I need to provide 2 of my first terms. So to find a2, I'm going to take 2 before it, or a0 in this case, times a1. So in other words, I'm going to take a2 and I'm going to multiply 1 times 2. I get 2. To find a3, I'm going to do a2, which is 2, times a1, which is also 2. To get a4, I'm going to multiply the 2 previous terms. So I'm going to multiply 2 times 4 to get 8. And then the 5th term, a5, I'm going to take 4 times 8. So again, it's the 2 previous terms, the 2 that came just before it. 4 times 8, and I get 32. That's my 5th term. This has been Recursive Rules.
Made with Doodlecast Pro.